Hi maths students, it's Mr. Hajgassim here, and today we're going to learn how to use tree diagrams to calculate probabilities. Now, two important things that you need to remember is that A, the probability of all outcomes will always add up to 1, and B, you need to be very confident in the way you label your tree diagrams. So here we have a question where it says Tina has 2 bags of counters, bag A and bag B. There are 5 red counters and 3 blue counters in bag A, and then there are 4 red counters and 5 blue counters in bag B. Tina takes at random a counter from each bag. Complete the probability tree diagram. So in bag A, you may be tempted to write 5 red counters and 3 blue counters. However, that would be wrong because we have 5 out of a possible 8. So to label the probabilities, we would have to do 5 out of 8, not simply 5. So the probability of taking a red counter from bag A is 5 out of 8 because we have 8 counters in total, 5 plus 3. And the probability of taking out a blue counter from bag A is going to be 3 out of 8. So be mindful of that. And 5 out of 8 plus 3 out of 8 is going to be equal to 1. So 5 out of 8 plus 3 out of 8 is equal to 8 out of 8, which is equal to 1. So the probability of all outcomes adds up to 1 for the counters in bag A. And then if we move on to bag B, it says there are 4 red counters and 5 blue counters. So in total, we have 9 counters, 4 of which are red. So 4 out of 9 is the probability of a red counter from bag B, and 5 out of 9 is the probability of a blue counter from bag B. Likewise here, this is going to be 4 out of 9, and down here we will have 5 out of 9. And once again, 4 out of 9 plus 5 out of 9 makes 1. So the probability of picking a counter is going to be 1. So the probability of all outcomes adds up to 1 here. Now, this is really important. And in terms of the total outcomes, so we can have red, red. We could have red, blue. We could have blue, red. And we could have blue, blue as well. And then from here, we can work out the probability of each outcome. And this is essentially what we're going to learn. So this is the outcome. And then how do we work out the probability of each outcome? Oops, sorry about that. I just moved this. And then we want to learn how to work out the probability in each case. So going on to our next example, which is quite simple. So it says 2 coins are thrown. What's the probability of getting 2 heads? So coin 1, we have 2 possible outcomes, either heads or tails. And the probability of each outcome is going to be 1 out of 2. We can either get 1 head or 1 tails. Second coin, again, here, let's say we get heads on the first coin. On the second coin, we could again get either heads or tails. So once again, we have 2 outcomes. Likewise, if we've got tails on the first coin, on the second coin, we have 2 possible outcomes, and that's going to be heads or tails, and the probabilities will still be the same. So on the second coin, to get heads, it's 1 out of 2. To get tails, it's also 1 out of 2. Now, so what is the probability of getting 2 heads? So heads and heads again. So if we write down the list of outcomes, we've got heads, heads, we've got heads, tails, we've got tails, tails, and we could get tails and tails. So the probability of getting heads, heads is 1 out of a possible 4 outcomes. So that's going to be 1 out of 4. Now, we could have worked this out a quicker way. So because we want heads, heads, we're going down this branch and then this branch again. So if we look at the red lines, as we go across the branches, we simply need to multiply the probability. So the probability of heads would be a half multiplied by a half, which is a quarter. So the probability would be a half multiplied by a half, which still gives us a quarter. So the reason why I did this was to show you why, as we go across our branches, the probabilities will be multiplied. Likewise here, if we wanted heads and tails, well, that's going to be heads and tails is going to be a half multiplied by a half. And that's going to be 1/4. Tails heads, again, is going to be a half multiplied by a half, which is 1/4. And likewise, tails is going to be a half multiplied by a half, which is 1/4. And if we have a look, the probability of all the outcomes, so we have 4 possible outcomes, and the probability of all the outcomes will add up to 1. So a quarter plus a quarter plus a quarter plus a quarter will add up to 1. Now, if we have a look at the outcomes, what's the probability of getting a heads and a tails? So we can either get heads tails or tails heads. So that's 2 out of a possible 4 outcomes. So the probability of heads tails is 2 out of 4. And again, another way of looking at this is if we add the probability of heads tails and tails heads, we would have, so probability of heads tails plus the probability of tails heads, well, that would be a quarter plus a quarter, which will give us 2 quarters, which is equal to a half. So heads tails or tails heads, that's going to be a quarter plus a quarter. So we add the probabilities in these cases. However, if we're going across the branches, we multiply the probabilities. All right, so let's have a go at another example. So here it says, find the probability of picking a blue and a white counter. Each time the counter that is picked, it's replaced. So counter 1, we have 1, 2, 3, 4, 5, 6, 7, 8 counters in total, 3 of which are blue and 5 of which are white. So the probability of blue is going to be 3 out of 8, and the probability of white is going to be 5 out of 8. Now, if we were to pick, if we were to replace the ball, so it says each time the counter is picked, it is replaced. So we take it out and then we put it back into the bag. So if we were to pick another counter, so pick the second counter, again, the probabilities will still be the same because the number of counters in the bag hasn't changed. So once again, the probability of blue is going to be 3 out of 8, and the probability of white is going to be 5 out of 8. And likewise down here. So what are our outcomes? So we can have blue, blue, we can have blue, white, we can have white, blue, and we can have white, white. So find the probability of picking a blue and a white counter. So the probabilities that we want is blue and white. So these two over here. So what we need to do is go across this branch and then this branch to get the probability of blue, white, and then this branch and this branch to get the probability of white, blue. So the probability of each outcome is simply multiplying the probability along each branch. So for blue, blue, we would have to do 3 over 8 times 3 over 8. That's going to be 9 over 64. For the probability of blue, white, we would have to do 3 over 8 multiplied by 5 over 8. That's going to be 15 over 64. Down here, white, blue is going to be 15 over 64, and white, white is going to be 25 over 64. And if we add all of these probabilities together, they should add up to 1. So 9 plus 15 is 24, plus 15 again is going to be 39, and 39 plus 25 is going to be 64. So the probabilities, all of the probabilities will add up to 1 in this case. But we just want the probability of picking a blue and a white counter. So as I've circled here, blue, white, or white, W. So the two probabilities that I'm looking for are 15 over 64 and 15 over 64. And I just simply need to add them together. So the probabilities here would be 15 over 64 plus 15 over 64, which is going to be 30 over 64. And I can simplify this to 15 over 32. All right. So this is an example where counters aren't replaced. Now, the second question here, it says, find the probability of picking a counter of the same color. So here we can get blue, blue, and we can get white, white. So we need to add the probabilities of blue, blue, and the probabilities of white, white. So we want 9 over 64 and 25 over 64. So in this case, we would have to do 9 over 64 plus 25 over 64. And that's going to be 34 over 64, which is going to be 17 over 32. All right. And moving on. So over here, this is where the counters are not replaced. So let's have a go at this question. It says there are 7 blue counters and 4 yellow counters in a box. 2 counters are removed and their colors are recorded. The counters are not replaced. Find the probability that the 2 counters will be the same color. So counter 1. So our tree diagram will look something like this. So we can either get blue or yellow, and the probability of blue is 7 out of a total of 11 counters, and the probability of yellow is going to be 4 out of a total of 11. Now when we go to pick the second counter, what we have to be mindful is that, let's say we've picked blue in the first instance. So the first counter that we picked is blue, and that counter is not replaced. So once we've taken the blue out, we haven't replaced it back into our box. So now, if the second counter is going to be blue, there are 6 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 counters, because like we said, 1 counter has been removed and not replaced. If we want a yellow counter, well, if the first counter was blue, the number of yellow counters is not going to change. We're still going to have 4 yellow counters, but that's going to be 4 out of 10. However, if the first counter was yellow, so if the first counter was yellow, what's going to happen is the number of yellow counters will decrease by 1. So the probability of the second counter being yellow is now going to be 3 out of 10. So we still have only 10 counters. And the probability of blue, well, the number of blue counters is not going to change, so it was going to be 7 out of 10. Now let's list our outcomes then. So our outcomes, we can have blue, blue, we can have blue, yellow, we can have yellow, blue, and we can have yellow, yellow. And then we need to work out the probability. So I'm just going to write probabilities. And the probability of blue, blue, well, that's going to be 42 over 110. And what we've done is 7 over 11 multiplied by 6 over 10. So we have to multiply the top and the bottom, the numerators and the denominators. And then we can have blue, yellow. So that's going to be 7 over 11 multiplied by 4 over 10. So that's 28 over 110. And then we can have yellow, blue. That's going to be 28 over 110 again. And then we can have yellow, yellow, which is going to be 12 over 110. And if we add up all of these probabilities, they should add up to 1. The probability of all outcomes will always add up to 1. So 42 plus 28 plus 28 plus 12 is equal to 110. And 110 out of 110 is equal to 1. So all of these probabilities added together will be equal to 1. So I know that the calculations I've made regarding my probabilities is correct. Now, what does the question say? The question says, find the probability that the two counters will be the same color. So I want blue, blue, or yellow, yellow. So I want this probability and this probability. So I simply need to add the probabilities together. So that's going to be 42. So if I just use a different color pen, probability of same color is going to be equal to 42 over 110 plus 12 over 110, and that's going to be 54 over 110. So this is an example where the counters are not replaced, so you just have to be mindful when you do your second probabilities. All right, let's do another example. So it says here, George has a bag of marbles, so it's quite similar to the last example. And it says there are 6 red and 4 white marbles. So let's say marbles. George takes out a marble at random and records its color. Without replacement or without replacing it, George takes out another marble. So we can say marble 1 and then marble 2. Find the probability that the two marbles are the same color. So again, very similar to the last question. So if I start by drawing my tree diagram, we have 6 red and 4 white. So 6 out of 10 will be red and 4 out of 10 will be white. And then once he takes out the second marble, once again, the second marble will be either red or white. However, the marbles are not replaced. So let's say if the first marble taken out was red, the second probabilities that we will get is we have 1, 2, 3, 4, 5 marbles remaining that are red out of a possible 9. And then the number of white marbles won't change if the first marble was red. So we'll still have 4 out of 9 marbles. However, let's say if the first marble taken was white, so we would have to get rid of a white marble. That's the marble that's not replaced. We're going to have 3 out of 9 marbles, which is still white, and then 6 out of 9, which are red. So it says find the probability of the marbles being the same color. So we have red, red. We have red, white. So outcomes, we have white, red. And we have white, white. And the probabilities are the same color. So I want red, red, and white, white. So that's going to be 4 over 10 times 3 over 9. So that's going to be 12 over 90. And the probability of red, red is going to be 30 over 90. So I simply need to add these two probabilities together. So the probability of same color will be 30 over 90 plus 12 over 90, which is going to be 42 over 90. Now, if the question, let's say the question had said, find the probability that the two marbles are of different colors. So I'm just going to cross this out and say different colors. What would the probability be? Now, as I said, if the probability of same color is 42 out of 90, then the probability of different colors has to be 48 out of 90, because the probability of all outcomes will add up to 1. Now let's calculate this then. Let's see if this is true. Now the probability of red white is going to be 6 times 4 is 24 out of 90. And the probability of white red is going to be 24 out of 90. So the probability of different colors would be white red or red white. 24 over 90 plus 24 over 90 will give us 48 over 90. All right, now moving on to a very challenging example. So this is where you will need to use some algebra to work out the probabilities. And this is, we're looking at grade 8, grade 9 type of questions. So here it says the ratio of, in fact, it starts by saying there are some red counters. Now, when it says there are some red counters, we don't actually know how many red counters there are. So the word some should indicate that we need to use algebra. So we have X number of red counters and some blue counters, and X number of blue counters. The ratio of red counters to blue counters is 3:1. So we can say we have red counters, and we can represent this as 3x, 3 lots of x, and we have blue counters, and we can represent this as 1x or simply x. It doesn't matter if you write 1x or x. So in total, we have 4x amount of counters. So if we start by drawing our tree diagram, and the reason why I know I need to draw a tree diagram is because it says 2 counters are removed at random. The probability that both counters taken are blue is 1 out of 20. So I can draw a tree diagram to represent this information. So counter 1. So we will have red and blue. So that's going to be 3x out of the total, which is 4x. And this is simply going to be x out of 4x. Now the counters are removed at random. The counters, it doesn't say whether the counters are replaced or not. So the fact that they're removed, it means they're not replaced in this case. So for the second counter, counter 2, again, we can have red or blue, and likewise red or blue down here. So if we take out a counter and we don't replace it, what's going to happen to the probability of the next red counter? Well, that's going to be 3x take away 1, take away 1 amount of red counters that were in the bag, over, well, the total number of counters is going to fall by 1, so that's going to be 4x minus 1. In terms of the blue counter, that's going to be x over 4x minus 1. If the first counter was red, that's not going to affect the number of blue counters that are remaining. Likewise, if the first counter was blue, well, that's not going to affect the number of red counters that are remaining. So we still have 3x red counters over 4x minus 1. But the total number of counters will fall by 1. So we would have to do 4x minus 1. And then down here, if the first counter was blue, well, the number of blue counters will fall by 1. So we would have to do 3x minus, oh, and it's not 3x, it should simply be x, because we had x amount of blue counters. So that's going to be x minus 1 over 4x minus 1. Now the question says the probability that both counters taken are blue is 1 over 20. So the probability of blue is going to be, so blue is equal to 120. Therefore, we said as we go across our branches, we have to multiply the probabilities. So x over 4x, and maybe I should start slightly higher up with a different color pen as well. So x over 4x, so blue multiplied by x minus 1 over 4x minus 1 is equal to 1 over 20. Now we need to simplify this and solve for x. So if I start multiplying the numerators, we can do x multiplied by x is x squared, and x multiplied by minus 1 is minus 1x, or just simply minus x, over 4x multiplied by 4x is 16x squared, and 4x minus 1 is going to be minus 4x, and that is equal to 1 over 20. Now, to get rid of the denominators, what I can do is multiply, cross multiply essentially. So multiply both sides by 20 and both sides by 16x squared minus 4x. So what I'll end up with is 20 multiplied by x squared minus x is equal to 1 multiplied by 16x squared minus 4x. Now, if I expand a bracket here, I will get 20x squared minus 20x is equal to 16x squared minus 4x. Now I need to rearrange so that one side of the equation is equal to 0. Therefore, if I take away 16x from both sides, what I'll end up with is 4x squared. And if I add 4x to both sides, what I'll end up with is minus 16x is equal to 0. Now, if I factorize this, so this is solving a quadratic here, which you may or may have not seen before, but this is where algebra is so important, and being able to solve quadratic equations is so important here. So if we factorize this, what we get is 4x on the outside multiplied by x minus 4, and that's equal to 0. Now what we need to realize here, one of these two, so either 4x or x minus 4, has to be equal to 0 in order for these two to multiply to give us 0. Therefore, what we can say is either 4x is equal to 0 or x minus 4 is equal to 0. In this case, x is equal to 0 over 4. 0 over 4 is simply 0. And x minus 4 is equal to 0. Therefore, x is equal to positive 4. So we're going to use this value of x because we can't have 0 counters. So x is equal to 4. It says work out how many counters were in the bag before any counters were removed. So what we need to do is multiply. We said the total amount of counters is 4x. If the value of x is 4, then that's going to be 4 multiplied by 4, which is 16. So there were 16 counters in the bag to begin with. And that would make sense. Let's see. So let's substitute 4 in here. So instead of x, we would put 4. So 4 over 16 multiplied by 4 take away 1 will give us 3 over 15. And then what do we get? So 4 over 16 times 3 over 15, that's going to be 12 over 16 times 15 is 240. And 12 over 240 is equal to 1 over 20. So I know my x value is correct. Now, just be mindful, this is a very complex example, and this is level 8, level 9 probability mixed with algebra. However, I thought I'd include this as a challenge question. Right, I hope you found this useful, and have a nice day. Bye.